welcome to the Unit 3 review. Wait, Unit 3 final review. Whatever. Whatever, you know what I mean. So, here we go. So this is Unit 3 starts with number 16. That's a lot of glare. Let me see if I can turn off the lights. Okay, we'll see if that's too dark. Let me give it a shot. Hold on, I got an email, 1 second. Where am I? Oh, there we are. Sorry. Found it. Okay, anyways. So it starts with number 16. Okay. $17x plus 72. It says solve by factoring. So notice the difference between, on Unit 2, it said factor. And it gave you like f of x equals this, and it told you to factor it. Okay, solve by factoring. You have an extra step. This is equal to 0. So we're trying to solve for x. What is x when y equals 0? That's what we're trying to figure out. And I want you to do it. There. I want you to do it by factoring. So, just like when we do it for Unit 2, you need factors of c, so factors of 72, factors of c, and they need to add up to 17. All right. I need to buy like bright colored markers. That would make me so happy. I wonder if I can do that. I'm going to look on Amazon. Sorry, sidetracked. Anyways, so factors of 72. If you can't think of any, you could always do a factor tree for it. Okay. Factors of 72. The first one, honestly, that popped in my head was 2 and 36. Now, so 2 times 36 is 72, but then we have to add them together. 2 plus 36 is 38. So it's not those. Those are not the correct factors. There's hold on. Okay. There is 4 and 18. 4 times 18 is 72. But do these add up to 17? They do not. This is 22. So no. All right. 72. This is where multiplication facts come in handy. 72 is also 8 times 9. 8 times 9 is 72. 8 plus 9 is, in fact, 17. So those are the factors we are looking for. Okay. So 0 equals, there we go, x plus 8, x plus 9. Those are not your answers. You're not done. Those are your factors. Your factors are 8 and 9. Okay? We're not done. What value of x would make this equal to 0? Okay, so if x is -8, -8 plus 8, I'll just do that, is 0. 0 times x plus, well, I guess this would also be negative 8, huh? Okay, but it doesn't matter. 0 times anything is just 0. So as long as one of these is equal to 0, you're good. So if it helps, you can put your factors equal to 0. X plus 8 equals 0, and x plus 9 equals 0. And then you solve for x. So x equals negative 8 and negative 9. So those would be your answers. X equals negative 8 and negative 9. If I were to graph this, it would cross my x-axis at negative 8, and negative 9. Okay, number 17 says solve by completing the square. Wow, I made my 0 really big. Solve by completing the square. Okay. So once again, you're trying to solve for x. And if I tell you on a test to solve by completing the square, you have to solve it by completing the square. Because you have to do what I say. Then once you get out into the real world, you can do what you want. But I have to make sure you know how to do it this way. So to complete the square, I would move c over to the other side. So I'm going to subtract 24. And then I'm going to rewrite it. So I'm going to have x squared plus 16x equals, this is gone, negative 24. Okay? So I rewrote it the other way because I like it better this way. And then I have negative 24 over here. Now you're going to complete the square on this side. So x squared plus 16x plus something equals negative 24 plus whatever that is. Okay, whatever you add on to this side to complete the square, you have to add on to the other side. Because what you do on one side of the equation, you must do on the other side. All right, so to complete the square, we learned how to do this in Unit 2. Unit 2. So that's where you go, b over 2 squared. So 16 is b. So 16 divided by 2. What's 16 divided by 2? It's 8. And then 8 squared. So 8 squared. 8 times 8 is 64. Make sure you add it on to both sides. Okay. Now, this is a perfect square. We just made it. So you write this as a factor. So it's x plus, since we know it's a perfect square, you just take half of your middle term. Half of your middle term squared. If you don't remember that, just remember you write it as a factor. Ooh. The factors of this are 8 and 8. 8 times 8 is 64. 8 plus 8 is 16. Equals negative 24 plus 64. Negative 24 plus 64. I'm not sure that's what I intended it to be, but all right, that equals 40. Hold on. Okay, sorry, I keep getting emails. So here we are. Some of you like to stop here. You're not done. You're trying to solve for x. So we need to get x by itself. So I have to get rid of my squared. That needs to go away. So I'm going to take the square root of both sides. Okay, because that will cancel out my squared, and what you do to one side, you must do to the other side. I made this one so you have to simplify radical. Gosh, okay. So these cancel out. X, you get x plus 8 equals, we're going to go ahead and simplify this. Okay, the square root of 40 is irrational. This is not a perfect square, but let's simplify it by prime factoring. Here. So here's 40. Here we go. 10 and 4, 8 and 5. Let's do 8 and 5. 8 times 5 is 40. 5 is prime. 8 is not, so keep on going. 8 is 4 times 2. 2 is prime. 4 is not. 4 is 2 times 2. Eventually, well, maybe. You might eventually memorize these. So the square root of 40 is the square root of all of its prime factors. 2, 2, 2, 5. 2, 2, 2, 5. You're looking for groups of 2 because it's the square root. So I have 2 2's, so I can pull out a 2. And then I only have one more 2, so that has to stay, and I only have 1 5. So 2 times 5 is 10. All right, so there, we simplified it. Hold on. So you get plus or minus, because square root, you're going to get plus or minus 2 square root 10. Okay? Your last step, because we're solving for x, is you're going to subtract 8 from both sides. Let me erase this. Okay. So you get x equals negative 8, plus or minus 2 square root 10. If you want to write it separately, you can. It would be x equals negative 8 plus 2 square root 10, and x equals negative 8 minus 2 square root 10. Okay? So that was number 17. Alrighty, number 18, solve by using the quadratic equation. Okay, so quadratic equation, I will always give it to you, but I mean, eventually in life, someone might make you memorize it, so it doesn't hurt, but I will always give it to you because it's something you can look up. So negative b plus or minus b squared minus 4ac all over 2a. Okay. So let's identify a, b, c. All right. A is whatever's in front of the squared, so there's nothing there, which means there's a 1. B is negative 6, and C is 3. Let me make sure I write down the problem right. R squared minus 6r plus 3. Okay, good. So here we go. Negative B. So you have a negative and a negative. So that makes it a positive 6. So I have positive 6 plus or minus b squared. So that's negative 6 squared. Negative 6 times negative 6 is 36. Okay, minus 4 times a, which is 1, times c, which is 3. All over 2 times a, and it is 1. So 2 times 1, which is 2. Okay. Well, I didn't say this. Make sure you pause me and try this first, right? You're trying this by yourself before you come to me. Alrighty. Better be trying it by yourself. 6 plus or minus. Oh, let me move this down a little bit. So that was step 1. Well, really, this was step 1. So I guess this is step 2. Then you have 6 plus or minus 36. And then multiply these 3 numbers together. So I have negative 4 times 1, which is negative 4, times 3. Negative 4 times 3 is negative 12, all over 2. All right, we're going to move this way. Okay. Let's go up here. 6 plus or minus the square root of 36 minus 12 is 24 all over 2. All right. So what do I want to do next? Now I would go ahead and simplify what's underneath my radical. So I have the square root of 24. So let's do it. How much room do I have? Sweet. 24. So 8 and 3, 2 and 12, 4 and 6. Let's do 4 and 6. 4 and 6 is 24. 4 is 2 times 2. 2 is prime. 6 is 3 times 2. Oh, my shadow. And those are prime. So the square root of 24 is equal to the square root of its prime factors. So 2, 2, 2, 3. 2, 2, 2, 3. Can we see that okay? Well, when I'm not in the way, I think so. All right, so you're looking for groups of 2. So I have 2 2's, so I'm going to pull out a 2. And then this has to stay in, and so does this. So that becomes 2 square root 6. All right. So 6 plus or minus 2 square root 6 over 2. I replace the square root of 24 with 2 square root 6 because that's what we got when we prime factored it. Too much going on now. Okay. So now you can divide by 2. So 6 divided by 2. 6 divided by 2 is 3 plus or minus 2 square root of 6 divided by 2. Your 2's are going to cancel out. So plus or minus the square root of 6. Voila! That is number 18. Fine. Oh, sorry. All right. For number 19, it says classify the roots of the following equation. Complex or real, if real, irrational, or rational. When you're classifying roots, use the discriminant. You could solve this using the quadratic equation, and then you would figure out the roots, and then you could classify them, but that's way more work. Use the discriminant. It is b squared minus 4ac. It is part of the quadratic equation. Okay. What is underneath the radical, this is called your discriminant. So, when was this? This was 3.9. Look back at your notes from 3.9. Actually, I'm pretty sure I also posted notes there. All right. So we're going to use the discriminant. I'm going to write it. Yeah. Okay, so let's see. This is A, B, C. A is 2, B is 10, C is negative 6. All right, so B squared minus 4AC. B squared is 10 squared, 10 times 10, 100, minus 4 times A, which is 2, times C, which is negative 6. Multiply these three numbers together. So negative 4 times 2 is negative 8. Negative 8 times negative 6. Negative 8 times negative 6 is positive 48. So you get 148. There. If you get a positive number, the roots are real. If you get a positive number, the roots are real. because that means you would be taking the square root of 148, and that is a real number. Okay, so we know it's real. Now, is it rational or irrational? The difference here, if it's a perfect square, then it is rational. So if you take the square root of 148, if you get a whole number, it's rational. If you get a decimal, it's irrational. Okay. 148 is not a perfect square, so your roots are real. And oh, that was a bad and sign. I'll just write it. Real and irrational. Okay, here we go. This is 19B. So same idea, you're classifying roots. So I would just use the discriminant. Here we go. Identify A, B, and C. A is 1, B is -8, and C is 16. Okay, and then substitute them in. So B squared, -8 squared. -8 times -8 is positive 64, minus 4 times A, which is 1, times C, which is 16. So then you have 64 minus, multiply all of these guys together. So -4 times 1 is -4, and then you have -4 times 16. -4 times 16. It's 64. -64. All right, and that is equal to 0. So that means you're taking the square root of 0. You would be taking the square root of 0. That's real. That is real. The square root of 0 is just 0. 0 times 0 is 0. The square root of 0 is 0. It's real and it's rational. Also, if you get 0 here, that means there is a repeated root. So it only crosses your x-axis once. That's what happens when you get 0. If you get 0, you have a repeated root. So it only crosses your x-axis once. So that means your vertex is on the x-axis. So if you get 0, that means your parabola has a vertex on the x-axis. It might not be over here, it might be over here, okay, but you have a vertex on the x-axis. So it has one repeated root. Okay, but it is rational. 0 is rational. All right, 19C. Yes, 19C. 3x squared plus 4x plus 3. You're still classifying roots, so I still highly recommend using the discriminant. All right, identify A, B, and C. A is 3, B is 4, and C is 3. Okay, substitute it in. B squared, so that's 4 times 4 is 16, minus 4 times A, which is 3, times C, which is also 3. All right, multiply these 3 together. So you have -4 times 3 is -12. -12 times 3 is -36. 16 minus 36. 16 minus 36 is -20. Okay, you have a negative number here, which means you would have a negative number underneath the radical. That is an imaginary number. So if you get a negative number, it is complex. Your roots are complex. If you get a negative number for your discriminant, that means you have a negative number here, which is imaginary, which is complex. So your answer here is complex. Complex numbers are just complex. They're not rational or irrational. That's real numbers. That happened on the test. Okay? If a number is complex, that's all you're going to classify it as complex. Not rational or irrational. Just complex. All right. Okay, number 20 says simplify. So, okay. So I'm just going to rewrite 3i for now. 4i squared. So, square both things. So 4 squared is 16. And then you have I squared. This was 3.9 that we learned this. I squared, I'll write it over here, is equal to negative 1. I squared equals negative 1. Memorize that, please. It's possible to figure it out, but just memorize it. So then I have 3i times 16 times negative 1. 3i times negative 16. Okay, and then just multiply these guys together. So negative 16 times 3. What is that? 32, 48. Negative 48i would be your answer there. And you would leave it like that. Okay, this is number 21. Your directions are still simplify. Do not multiply these together. You are subtracting. You are not multiplying. So this becomes 6i plus 7. Just rewrite this one. And then minus 4i. You're basically distributing this minus sign. So it becomes minus 4i. And it becomes minus negative 3. Minus negative 3. So that turns it into a positive 3. Be very careful with signs. Okay, now you're combining like terms. So I have 6i and negative 4i. So 6i minus 4i is 2i. 7, and then you have, oh, some of my lights came on. I was like, it got brighter. You have 7 plus 3. 7 plus 3, which is 10. 2i plus 10. And leave it like that. You are finished. Oops. Okay, number 22. Simplify. So, simplify what's underneath your radicals. Can I simplify the square root of 50? Yes. Let's do it. So 50 is 5 times 10. So 5 times 10 is 50. 5 is prime. 10 is not, so keep on going. 10 is 5 times 2. So the square root of 50, are we good down here? I think so. Equals the square root of its prime factors. 5, 5, 2. 5 times 5 times 2. Okay. Looking for groups of 2, so I have 2 5s, so I can pull out a 5. The 2 has to stay inside, it's all by itself. So I have 5 square root 2. So 3 minus 5 square root 2 plus 7. And then we have the square root of 72. So all I did was replace square root of 50 with 5 square root 2. All right? Let's do the same thing with 72. So 72 is 2 times 36, or 8 times 9. I'm going to do 8 times 9. 8 times 9. Neither are prime, so you have to keep going. 8 is 4 times 2. That's prime. 2, 2. Oh, you can't quite see me. Move over this way a little bit more. Boop, 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 boop. And then 9 is 3 times 3. 3 times 3. All right, so we'll go down here again. The square root of 72 is equal to the square root of its prime factor. So I have 3 2's. 1, 2, 3. And I have 2 3's. Okie doke. So, square root. So you're looking for groups of 2. I have 2 2's, so I can pull out 2. And then I have 1 2 left over, but he has to stay because he's all alone. He's the only other 2, so he has to stay. And then I have 2 3's, so I can pull out a 3. So 2 times 3. And then on the inside, I have square root of 2. 2 times 3 is 6. So this becomes, oh boy, my handwriting is getting a little softy. So this becomes 6 square root 2. So the square root of 72 becomes 6 times the square root of 2. All right. Woo! Now you can combine things together. So I have 3, nope, and I have a 7. 3 plus 7 is 10. I have negative 5 square root 2 and 6 square root 2. 6 minus 5 is 1. So that is just, if you want, you can write the 1, but you don't have to. So it's just 10 plus the square root of 2 is your final answer. Leave it like that. The last thing you need to be good at for Unit 3 is classifying numbers. Okay, complex. All numbers are either complex, as in imaginary, or they're real. Okay, if they're real, then you have different classifications within there, rational or irrational. If they're rational, then are they integers? If they're integers, are they whole numbers? So 3.8, I posted a chart that hopefully you all wrote down in your notes. It's a colorful chart. I posted it on Canvas. Look at 3.8 notes. It's on there. Make sure you understand those. If you do not, ask me questions, email me, text me, ask me in class, something. Okay, you need to be able to classify your numbers. Okay, I think that's all I have for you.